Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Today we have 24th lecture and the topic is boiler firing sequence and its fuel oil system. In this lecture we will first learn boiler starting sequence. Then we will discuss about boiler fuel oil system. Lastly, we will discuss how the viscosity or temperature of fuel oil is controlled. This sketch describes step-by-step procedure for starting up the boiler. To start the boiler, supply of the burner panel is switched on by closing the main breaker. So we can see this is the burner panel supply and these are the main breakers. As soon as burner panel power is switched on, pump starts circulating fuel oil into the system through filter and heater as required by the characteristics of oil. So we can see that fuel oil is circulated with this pump through the filter and heater, and this three-way valve will start recirculating and the temperature will be required if we are using heavy fuel oil. If we are using diesel oil, no heating is required. Boiler is equipped with some interlocks and trips such as burner in place, low water level, high steam pressure and flame failure to protect it from damage and prevent injury to personnel. So we can see here the flame failure trip, the low water level trip, the burner in position. So this is an interlock, and in addition we also have high steam pressure trip. Burner can be started manually or automatically through the pressure switch by pushing the reset button when all critical conditions are normal. Flame failure is bypassed during the starting period. So we can start the boiler. If we wish to start manually, we have to close the switch, or if it starts automatically, the pressure switch will make and break the contact to start and stop the boiler. If all these conditions are normal, then reset is not required, but if any of the trip has occurred, it requires resetting this switch to make the contact. And during the starting, the flame failure is bypassed for few seconds. Forced draft fan B starts purging the furnace to drive out any accumulated fuel or exhaust gases in the furnace. This prevents the possibility of furnace explosion due to buildup of excessive pressure. So this pre-purging and post-purging, they are essential to prevent explosion of the furnace and should be always carried out. Timer T monitors the purging cycle, which usually is 3 minutes, after which it closes the contact for ignition. At the same time, vanes of the FD fan are turned to reduce the airflow for establishing the flame. So when the approximately 3 minutes are over, this will make a contact, and then the supply for the ignition transformer and the pilot burner pump will be on. On completion of the circuit, ignition transformer provides spark due to high voltage discharge, and ignition pump starts to provide diesel oil to the pilot burner. As soon as the flame of the pilot burner is detected by its photocell, it completes the circuit for the solenoid valve and admits the fuel to the main burner. So we can see here, this is the photocell for the pilot burner. Now this contact was not made until unless the pilot burner flame is visible to the eye. And when it is visible, this will close the contact, and this circuit for the solenoid valve will be completed, and fuel oil will start going into the burner, into the main burner in the furnace. As soon as flame of the main burner is detected by the photocell, it cuts the supply to ignition transformer and ignition pump. So when the main burner fires, this photocell will see the flame inside, and this bypass which was provided initially will be cut off, and these connections are broken. So the supply to the ignition transformer is cut off, but we need to provide the supply for the solenoid valve, so that is completed through this circuit like this here. If the main burner fails to establish main flame, boiler trips due to flame failure and cuts off the supply to the fuel oil solenoid valve. So in case the flame is not established, this contact will be broken by the flame eye around after say 30 to 35 seconds, and then once again the supply to the solenoid valve will be cut off, oil will stop going into the main burner and will start recirculating once again. So this describes the starting sequence for the boiler burner. This sketch shows the layout of boiler fuel oil system. Boiler is started on the diesel oil when it is in cold condition. So we can see the boiler furnace having its pilot burner and main burner. Diesel oil is supplied to the boiler from MDO, settling or service tank, which is usually situated above the boiler. Before starting the boiler, diesel oil is circulated through the circuit by one of the pump, and NRV prevents contamination of diesel oil by heavy fuel oil. So we can see the diesel oil starts circulating through this valve, through one of the pump, through its filter, and it is passing through the circuit. The heaters are not required at the moment, and it starts circulating over here, and this is the valve through which it returns. Fuel oil controller regulates the oil supply pressure as per the command of the combustion control system to maintain steady steam pressure. So this will regulate the fuel oil pressure depending on how much combustion rate we need. Boiler is always lighted up by the pilot burner using diesel oil, which is supplied to the ignition pump through filter and solenoid valve after the furnace purging during the firing sequence, which we have studied in the starting sequence. So we can see this diesel oil is coming through this filter, through the ignition pump, and it reaches the solenoid valve, and when the ignition command is given, the solenoid valve will open, and after the main burner is ignited, this pilot burner pump goes off and the solenoid valve closes. When the flame of the pilot burner is detected, photocell opens the solenoid valve for the main burner and fire is lit. So we can see that the oil was circulating. Now when its flame is visible, photocell will activate this valve and the fuel oil to the main burner will start and it will also start firing. When steam is available, diesel oil is heated in the fuel oil heater. So we have two fuel oil heaters. Anyone can be used for heating up the oil before changeover to heavy fuel oil. When temperature reaches to 90 degrees Celsius, HFO from the settling tank is supplied through the changeover valve and temperature or viscosity is maintained. So when we change over, we have to operate this valve remotely and the heavy fuel oil will start circulating into the system. Automatically the supply of diesel oil will be cut off and we have to maintain the temperature of the oil corresponding to the required viscosity, which is 15 to 17 CST in case of boiler. This valve V2 is provided for quick changeover from HFO to MDO if steam pressure drops due to failure of the boiler. So when there is emergency, because we cannot keep unheated fuel oil in the lines as it will freeze up and will cause lot of difficulty in restarting. So in such a instance, we have to open this valve V2 and we can close the valve V1 so that the diesel oil which is entering from here, it flushes the complete system and the heavy fuel oil from the line is going into the settling tank, and when sufficient oil, say about 500 liter of diesel oil passes into the system, we can assume that line is flushed and boiler can then be stopped. So this is the boiler fuel oil system. This sketch shows the construction and operation of viscotherm used for measurement and control of fuel oil viscosity. Viscotherm consists of specially shaped housing fitted in the fuel oil system after the fuel oil heater. So this viscotherm is placed in the fuel oil system, which we have not seen in the earlier diagram because it is used on the main boilers, and this will measure the viscosity of the oil flowing through this pipe and will be maintaining the required temperature to maintain desired viscosity, which is 15 to 17 CST in case of boiler. So the oil enters from the bottom here and leaves from the other side. This housing encases a gear pump which is driven by electric motor through magnetic coupling. The purpose of providing magnetic coupling is to avoid leakage through the glands or seal. This gear pump draws small quantity of oil and discharges into the capillary tube which provides laminar flow. The differential pressure transmitter compares the flow through the main pipe with reference to laminar flow passing through the capillary tube. So, the sample comes from the capillary and another sample comes from the main pipe, and accordingly it will give an output. Differential pressure transmitter receives an input signal of 1.5 bar and gives an output signal of 0.2 to 1 bar, which is used in the pneumatic control system. In the next diagram, we will see how the automatic viscosity control works. This sketch shows the schematic layout of viscosity control system. So, in the diagram what we see, we have a controller, we have a recorder, and this is the differential pressure transmitter which is measuring the input with reference to the laminar flow in the capillary tube and the flow through the main pipe. This will give an input to the controller and same will be recorded, and this controller receives a supply and gives an output signal as per the calculated differential between the set point shown by red indicator and measured value by the black indicator. The corrective signal will be given to this actuator and that will control the supply of steam to the heater, and that is how it is working. So, we can see that fuel is passing through the heater and this is the gear pump which is providing the sample. So, fuel oil is supplied through the heater and viscotherm for control of its viscosity or temperature. Differential pressure transmitter compares the turbulence in flow in the main pipe with the laminar flow as reference in the capillary tube supplied by the sample pump. Rise in turbulence indicates reduction in viscosity. Output of the differential pressure transmitter is calibrated directly as viscosity and fed to recorder and to the controller as measured value. The controller compares the measured value with respect to the set point shown by red and gives the corrective output signal to control valve for regulating the steam supply, which passes through the heater and leaves as condensate through the steam trap, which recovers complete latent heat in the system. So the control of the steam is done by this actuator operated by this controller, and this trap will ensure that no steam leaves the heater for recovering all the latent heat in the steam. This completes the study of boiler starting sequence, its fuel oil supply and method of viscosity or temperature control system. This book is written by me and covers all the topics as per Indian Maritime University syllabus. It is also recommended by Indian Maritime University as a reference book. It clarifies the concepts with simple illustrations. This book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. This book can help the students in preparing for the exam and also to work on ship's boiler safely. Hope you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.